In my last video, I explained what is mathematical modeling. What is mathematical modeling, and what are the different steps involved in mathematical modeling. Now, today I consider some examples on this. We start with some basic examples, and then I explain some standard established mathematical models, and then application of mathematical modeling to some complicated problems also. Now, what is mathematical modeling? Mathematical modeling means it is the technique of solving the real world problem which requires physical insight to solve the problem. We convert first that problem into mathematical language, then we solve that problem by using some mathematical branches, trigonometry, algebra, geometry or calculus. Then we interpret again that solution in terms of the original problem, and that technique is called mathematical modeling. And what are the different steps involved in mathematical modeling? Some question may be like this: define mathematical modeling. What is mathematical modeling? What are the different steps involved in mathematical modeling? Explain. What is the first step? First step is you have to understand the physical situation. What is the given problem? Physical situation. Second, convert the problem into mathematical language. Mathematical language. Mathematical language means you have to convert, you have to introduce some variables, parameters, and convert the problem into mathematical language. Now, third step is find the solution for the problem. When you convert the problem into mathematical language, you have to apply any technique or you have to apply any branch of mathematics to solve that problem. This is the third step. Fourth step is you have to interpret the solution in terms of the original problem. Third step, find the solution. Fourth step, interpret the solution in terms of the original problem. Fifth step is final, that is, if this result is in good condition with the observation or experiment, then you accept that solution and accept the model, and if it is not in good condition, then you have to change this problem, that is model. Here we will get a model, in the second step we will get a model, and that are the different steps involved in mathematical modeling. Now I consider some problems. We start with some basic problems. Already you have studied that problems in trigonometry, algebra and so on. We consider or we start with some basic or simple problems of that type. First is, I explain, see in first problem I explain step by step, means all the different steps 1, 2, 3, 4, 5. Later on, we do not go or explain one by one step. We directly solve the problem. We find a model and solve the problem. Find the height of a tower. Height of a tower. This is the problem. Apply mathematical modeling to find the height of a tower. Now suppose this is the tower. Say I consider this as a tower. You can visualize or you can realize that tower means that mobile signal towers. All of you know that tower, it is very tall. Without climbing, without actual measurement, we find the height of this tower. So first step is, what is the problem? You have to visualize what is the physical situation. Physical situation is like this. Suppose this is the ground level. This is the ground level. This is the ground level, and suppose this is the observer. This is the position of the observer. Now I take PQ is the position of the observer. PQ is the position of the observer, and AB is the tower. AB is the tower. That is, top of the tower is A, and foot of the tower is B. This is the foot of the tower, and PQ is position of the observer. Observer means the height of the observer is suppose h, and suppose height of the tower is capital H. Height of the tower is capital H. Now this height, I draw the perpendicular like this. It is C. It is. Then since this is H, this is H. What is AC? AC is H minus small h. H minus small h. See, the first step is we have visualized the problem. What is the physical situation? What is the problem? First step is we have to find the height of the tower. We know the tower here, and PQ is our position. PQ is the observer. Now through this line, we observe the top of the tower through this line. You have to imagine, suppose this is the position of the observer. Then how do you see the top of the tower? Top of the tower we see through this line. This is called line of sight. And suppose alpha is the angle made by this line of sight with the horizontal through the observer. This is the eye of the observer. Our height is small h. Then alpha is called angle of elevation. Alpha is called angle of elevation. Now we have introduced the notation here: alpha, capital H, small h, so on. Now we apply trigonometry here. By trigonometry, one more notation we use here. We require PC also further. We take this as small l. From trigonometry, this you have to write here. You have to we have introduced here capital H, small h, alpha, PQ, and ABC. All this you have to write in the first step, explanation. Now from trigonometry, from triangle APC, tan alpha is AC by PC. AC by PC. So tan alpha is AC means H minus H upon L. Therefore, H minus H is tan alpha into L. Capital H is L into tan alpha plus H. L into tan alpha plus H. We take this as 1. So height of the tower is given by L into tan alpha plus H. See, in the right hand side, L, alpha, H are parameters. L is known because we can find out L. By actual measurement we can find out L. Because if foot of the tower and the person are like this, and we can find out this length. That is, what is that? L. And what is small h? Height of the person. And alpha is angle of elevation. And this we find out approximately. We cannot use a compass here. We cannot use protractor to find the angle. We cannot use the protractor because we have to imagine here a line of sight and we have to find out approximately alpha. How accurately you find out alpha, or how accurately you approximate, how accurate your approximation, that gives the accurate value for H. So H is L tan alpha plus H. Since H, L, alpha are known, height can be obtained. Now sometimes what happens, this foot of the tower is it is not possible to measure this length. What is that? QB or L. In that case, what we do is we take this as beta here. We take this angle as beta. What is this? We observe foot of the tower from this point and we take this as beta. In that case, h by this is beta, therefore this is beta, correct? So h by L, this is beta, therefore this is beta. H by L is tan beta, therefore L is equal to h cot beta. H by tan beta, that is h cot beta. Therefore we can substitute L as h cot beta. L as h cot beta, and we can further find out we can find out the height of the tower. Say we introduce this again beta only when it is not possible to measure L here. Practically, suppose it is not possible to measure L. It is difficult to go to the foot of the tower. It is difficult to go to the foot of the tower. Then what happens? We imagine angle here. That means we imagine a line here, or this is called line of sight. We observe the foot of the tower to this through this line. That is called line of sight. And suppose this is beta angle. Then L is given by h cot beta. Substituting L here, we can further modify, or we can get the more accurate answer. Now this is the model for the problem. What is that? H is equal to L tan alpha, capital H is L tan alpha plus H. This is the mathematical model to find the height of the tower. Second, write a model for the quantity of water in a pond in a village. See, problem is write a model for the quantity of water. How much quantity of water is there? See, in this case we cannot measure the quantity of water by actual measure. We cannot measure actually, or practically we cannot measure how much water is there in a pond. For that, we now have a model. We write a model for the quantity of water. Suppose the pond is like this. This is the pond, and this is one side of the pond. This is one side of the pond, that is bank of the pond. This is the pond, and we have approximated the pond is in the shape of the parabola. Can you realize this one? Pond is in the shape of the parabola. Suppose this is the pond, given pond. If the pond is rectangle or a square, then it is no problem. We can easily write the model. But always it is not rectangular, or it is not a standard circle or ellipse, so on. Correct? Ellipse. It is approximately the shape of the pond is like a parabola. Now, suppose this is the water here, and how much depth let us consider later. Suppose A is the area of this pond. Then the shape of the pond is in the first step is, suppose shape of the pond is like a parabola. a parabola. Then A be the area of the pond. A is, what is the area? Area of the parabola. Then we have shape of the parabola is, we have to find out the area first. Then area into height, depth. Area into depth gives quantity of water. First we find out area. For that it is y square is 4ax. Now we find out this area. This area. We use here, for that we use calculus here to find the area, because you know that in integral calculus, integral a to b y dx represent area under the curve. Area under the curve. So if a is the area, then a is integral 0 to a y dx. 0 to a y dx. Because this is focus here. This is vertex. What are the coordinates of the focus? A0. Therefore, A is it twice it is? Yes. A is 2 into 0 to a, because you will get area, this area as 0 to a y dx. We consider this as x axis. What is this area? 2 into 0 to a y dx. So A is 2 into 0 to a, y is 2 root a root x dx. So 4 root a integral 0 to a root x dx. See, what is the first step here? First step is we have visualized what is the problem here. Problem is we have to find out water quantity in the pond, and we have approximated the shape of the pond is parabola. First we find out area, then quantity of water is, volume of the water is area into depth of the water. First we find out area. 4 root a x raised to 3 by 2 upon 3 by 2 0 to a. What is this? Area. Therefore it is 8 by 3 root a and a raised to 3 by 2. Therefore 8 by 3 a square. What is this? Area. Suppose h be the, we introduce one more parameter here, h be the height or h be the depth of the water. H be depth of the water. Then volume of the water is, the quantity of the water is in the pond is less than or equal to 8 by 3 a square h. I will denote this by W. W is 8 by 3 a square into h. This is less than or equal to, why I have taken less than or equal to is, h is maximum height at all the points of the pond, all the positions of the pond. Height is not h here. Maximum height is h. Therefore maximum water is, it is 8 by 3 a square into h. But quantity of the water is less than or equal to 8 by 3 a square h. This is the model. What is a? That focus distance. A is that distance. We have assumed the pond is like this. This is a. This length is a. That also you have to mean you have to find out approximately a. You have to find out a, and h means depth of the water also. You have to imagine, or you have to approximately you have to find out, because practically it is not possible to find out the height. We suppose that is the problem. Practically it is not possible to find the height. In that case, this serves as a model. Next problem is, you take this. A company wants to buy a rectangular plot of 10,000 square meters. 10,000 square meters. The price is rupees 50 per meter of the length. Rupees 50 per meter of the length on the main road. And 20 rupees per meter of length on the other three sides. Find the sides of the cheapest plot the company can buy. I repeat, a company wants to buy a rectangular plot. Suppose this is a rectangular plot. Company wants to buy this plot. Suppose L and B be the dimensions. Here what happens, suppose this is the main road. Along this side, the cost of the plot is fixed like this. Cost of the plot, price of the plot. Along the main road, for per meter length of the plot, it is 50 rupees. And other three sides, 1, 2, 3, these three sides, it is what is the rate of the plot? 20 rupees per meter length of the plot. Now problem is you have to find out the dimension of this for which the plot is cheapest. Means length and breadth you have to find out for which the cost becomes cheap. Cost becomes less. I think first step is clear. What is the first step? First step is you have to visualize the problem. What is the physical situation? What is the given problem? You have to visualize. You have to understand. That is the first step. I think that you understood what is the problem. You have introduced here. Second step is you have introduced the parameters here, L and B. In this step, second step, you have to form a model here. You have to convert the problem into mathematical language. That is called model. What is the problem? Suppose this is the rectangular plot and L and B are the dimension. This side is along the main road and other three sides the rate is different. For this side rate is different. Per meter it is fixed. So first step is over. What is first step? You understood what is the problem here. You know the physical situation. What is the problem? Second step is we introduce some notations. L and B be the dimensions of the plot. Then L into B is 10,000 square meters. 10,000 square meters, L into B. This is, take this as 1. Then you know that rate per meter along main road 50, other three sides 20 rupees, that you know. Now what is the cost of the sides? I will write this as cost function. I call this as a cost function. Cost of the side is, I denote this by LB because it is a function of two variables. Cost of the side is CLB is, it is 50 into L plus 20 into B plus, because 50 rupees on the main road, 20 rupees on this side, 20 rupees, therefore 20 into B, 20 rupees along this side, therefore 20 into L again, plus 20 into B. 50L, 20B, 20L, 20B. This is important step now. Say cost is not same. On the main road it is 50, therefore 50 into L. On this side 20, therefore 20 into B. On this side again 20 rupees, therefore 20 into L. Distance is L. And on this side again 20 rupees. This is the cost function. It is therefore 70L plus 40B. This is cost function. But it is a function of two variables. We express. Now what is the problem? You have to minimize this C. Once we convert the problem into mathematical language, then we can use any branch of mathematics. Usually trigonometry, calculus, algebra, geometry. We can use any branch of mathematics. But here we use calculus. You have studied maxima and minima in calculus. What is the maxima and minima? What are the necessary sufficient conditions? First derivative is 0 for maximum or minimum. If second derivative is negative, function is maximum. Second derivative is positive, function is minimum. That is maxima and minima. I apply that technique here. But this is a function of two variables. I express this as function of single variable. For that, use 1. From 1, 70L plus 40. What is B? B is 10,000 upon L. Take this as 2. Now we have established a model here. This is the cost function and we have to minimize this. Next thing is very simple. To express the word problem into mathematical language is important. For that we have to introduce some parameters. Now once if we obtain this one, next step is we have to minimize CL, cost function. For that, first derivative d by dl of C is, I use here 70 minus 1 upon L square into 40 into 10,000. This is 3. For maximum or minimum, d by dl, first derivative is 0. This implies 40 into 10,000 upon L square is equal to 70. Therefore, L square is 10,000 into 4 upon 7. Correct? 10,000 into 4 upon 7. So I take here, answer is 5714.29. What is that? L square. Therefore, L is 5714.29. No, it is L square. L is therefore 75.6 meters. I have used you can use calculators here because I have lengthy calculation here. It involves a large number. 5714 L square, L is 75.6 meters. Now what is this? Here for maximum or minimum value L is this. But how to get whether it is maximum or minimum? D to C by dl square. It is minus of 40 into 10,000 into minus 2 by L cube. Derive this. Differentiation of this. It is positive. That is we require. Actual value is not required. Sign is required. Positive. This implies C is minimum when L is 75.6 meters. And from 1 when L is this 75.6, B is 132.3 meters. 132.3 3 meters. You verify this again. I have substituted in 1. Now, therefore, what is the conclusion? Final conclusion. The cost will be cheapest for this site when along the main road you have to choose the length as 75.6 meters and other two sides 132.3 meters. Then cost will be minimum. Now this is how we can solve some problems using mathematical language. I have taken some simple problems. I continue some more examples and I continue and solve some more examples in the next period. Okay, thank you.